Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hello everyone, my name is Filipi Pires and today we're going to talk about how you can keep your code and safe during the development path, right? So my name is Filipi Pires and I've been working as Principal Security Engineer at Talkdesk. By the way, Talkdesk is a company from Portugal responsible to provide some contact center as a service, as a product actually. And I'm security research at Senha Segura, right? So Senha Segura, it's a Brazilian company, but they have many customers around the world. They appear in many different reports, like a Gartner, like a Forrester, like a KuppingerCole. It provided some solutions of the PAN, Privileged Access Management, and I'm security advocate and security instructor about many topics related to security, right? So. And I'm I'm advocate of this awesome project, Hack is Not a Crime. By the way, this project, it's pretty awesome because the idea here is to explain more about the concept about the hacking, right? Because hacking is really not a crime. It's a mindset, it's a life cycle. So how you can look into some software, for example, and how you use your creative mind, okay? And I'm a contributor of the Red Team Village. It's a pretty nice community in the US. I'm a speaker there and I'm talking in many different events. And I'm a part of the staff team of the DEFCON groups here in São Paulo. It's a community here. And I'm a creator and instructor of the malware analysis course of malware attack types with Qchain. It's a kind of technique using in an offensive exploitations using the concept calling malware. This is my web page. If you'd like to see more information about me, other talks that I'm doing, or I'm not doing, but talks that I'm made in different events, different talks that you can see here. And here I have here some articles published about different topics related to cybersecurity, right? And here you can find Filipi X 86. Actually, this is my main GitHub here. You can see more information about my projects, about some things about me. Okay, so let's talk about our main topic today, about how you can improve your code actually. So as you can see here, I don't know if it's small, but here I have in my GitHub or sec-demo. This is my project that I will be using here during this demo, during these presentations. I have here different codes vulnerable, right? So you can copy that after this conference or this meeting, and you can use this in your presentations or your tests in your demo, okay? So first of all, I would like to explain more differences about some concept, because I would like to put all those people in the same page, okay? So that's a simple definition about what is exactly SAST, DAST, and EAST difference, okay? So SAST is a statistical application security testing. It's a pretty important step when you create some software, okay? When you develop something. Remember, when I'm talking about the software development lifecycle, but I will put the another S, DLC, so secured software development lifecycle. So you can use in this a strategy or this method during your development process or development path. Okay, so SAST analyzes the source code of the system or that you're using before you're putting this code in the productions. Okay, tests are usually performed before the system, as I mentioned, is in productions and only in the source code. The idea here is to scanning your source code to see if you find some vulnerabilities in this code. The point important here is RSAC is an open source project that you can see. I will put here RSAC in the internet, for example. You can check here, and I will explain more about what is exactly RSAC during this presentation, okay? Another point is DAST is a dynamic application security test. Is another approach, okay? The DAST tests expose the interfaces for a vulnerability. In this case, it's different when you compare to SAST, okay? In this case, DAST is great for finding externally visible vulnerabilities, so after the publications, okay? It tools recommended to find vulnerability externally visible. I mean, you need to publish this URL to be tested is enough to perform the test, or a binary to be executed. So this is an important thing. So you have another different techniques that you can use in this analysis, like SCA or container scanning. So part of the process using in this development path. Okay. So EAST is another interactive application security test. You combine these two different strategies. Okay, just to be clear. When we talk about the vulnerabilities in some codes, it's pretty important to understand some difference. So you have some levels about the security, right? When you find some vulnerabilities, probably you know, but if you don't know, it's pretty important to clarify this, okay? So first, it's critical, it's too high, and the second is high, medium, low. It means this is the definitions about the vulnerability. And here in this case, but this explanation is related to this tools, in this case, RSAC, is info. I mean, when you receive some info about the log, and no, probably we don't have any information about this. Maybe something is suspicious, but it's not clear if it's malicious or not, or is it vulnerable or not in this case. Okay, so how this is how you can using these explanations related to these tools, in this case RSAC, right? And okay, so this is just to clarify something related to this main topic about the security and software development life cycle. Okay, so let's talk about what is exactly this open source tools RSAC. Okay, open source RSAC today is maintaining for Zup Innovation. Zup Innovation is a Brazilian company, by the way. It's my previous job. Okay, and this tool is responsible to identify vulnerabilities simple and fast. Here is the explanation. RSAC is an open source tool, again, that performs statistical code analysis, as I mentioned, to identify security flows during the development process. So here it's a good point here. Okay, currently the language and tools for analysis are C#, Java, Kotlin, Python, Ruby, Golang, and take a look at this, the Terraform and Kubernetes, and another like a JSON, Elixir, Shell, and so on and so on. Okay, and another point here, pretty nice in these tools, is it has option to search for key leaks and security flows in all files of your project, as well as in a GitHub history. So you can using the RSAC tool in the developer through the CLI, and by using the DevSecOps team on CI/CDs. I will explain more during this conversation. Okay, just to clarify what is exactly this tool. So here we have a web manager to manage the vulnerabilities, and you can using this in your pipeline as well. It's pretty nice because you can improve your pipeline. Okay, so here's some explanations on how the RSAC works. You can read after this presentation the documentations. Okay, so let's return here in the documentations. So if I click here in RSAC, take a look at this, I will fall into the main page here, as you can see, just to explain you. Okay, let me close this another tabs. Another point is you can click here, for example, let me clear just in the main page. Not main page, let me put here again RSAC here one more time, RSAC. I will explain the main page here, rsac.io. You can click here on a GitHub to see the main page in a GitHub. As you can see here, you can check all those informations here about what it is exactly, the documentation, so and how you can contribute more in this case from this awesome project, by the way. Okay. Another point in this documentation is you have here the docs and the community. You have here the forum. You can interact with another people from the community. Here you have the English page of RSAC. You can open here many cases, or if you have some error using RSAC in a GitHub Actions or using your pipeline, So here you can see you can using this to exchange knowledge with the community. Okay, so pretty nice that you have these opportunities. Okay, so let's return here in the documentation. It's here. Okay, and I will click here in a CLI, and I'm using here the installation process. So pretty simple. I will install here in my Linux machine. I will be using curl here, as you can see. I have here, by the way, the main directory that I have, the same codes vulnerable as you can see here in my virtual machine. So first of all, you pass here, and as you can see, I will be using the curl to request this binary to install in my virtual machine. And after to install, as you can see, I'm downloading, and I will move this binary to the local bin, as you can see here, because I can execute this binary in whatever place I have inside of my virtual machine. So now I have here the RSAC in my virtual machine. Okay, so I will set -h to see about what kind of command I can use here. So as you can see here, I can use into two different ways, like a flags and like a comments. Comments, I mean, it's available comments that you can use in the start to start or set CLI version to see the version, but basically and generate and completion. Okay, but I mean the main command that you will use in the start, because I will be using the CLI executing RSAC. So RSAC start, and after that I'll set the -h to see about what kind of flags I can use here. And if you see, I have many flags to use here. So here a simple explanation is start the RSAC analysis in your current path. I mean, when you execute this, just by default, you will execute this in RSAC-demo because this is the current path. Okay, so I can set, by the way, if you would like to analyze another different directory, for example, another folder, I can set, for example, -p like this. Let me show you here. -p here, -p. I mean the project path. Okay, so for example, in this case, I am in this path, but if I will set here -p, I will write another different folder to analyze this. It's pretty simple and very, very intuitive how you can use the CLI. And you can set, for example, -a, I mean, it's authorization. In this case, the authorization token is responsible to send all those informations about the vulnerabilities to a web manager or a SEC web manager, okay, that you can manage it, all those vulnerabilities and that you find in your code in this platform. If I have a time, I will explain during these presentations, okay? So another point is, if you use some another qualicolor like a Sonar Cube, for example, and you have here -o to set the output format, and as you can see here, I can send the output format to integrate with the Sonar Cube, because in Sonar Cube you have the qualicolor software and tool or tools, for example, and of course in Sonar Cube you have some version with a security stuffs in this different version. I think it's an enterprise version, I don't know exactly, but RSAC, it was developed by the security team from Sup Innovation, so it's a different, right? So when the team created the engine responsible to analyze this, it's a security team, so the essential of this tools is from the security team. So this is some difference, but you can, it's a good recommendation to use both of them, because Sonar Cube is more focused in a quality code, and so RSAC it's a focus in a security code. Okay, so let's execute to see how this works in my environment, for example. So let me set here. Let's check here. I have an Golang. Let's see, for example, I will execute this RSAC. No, Hopper, sorry, RSAC start, and I will set -p. Okay, and I can put here for example, different path. I will execute this in the main path here. I'll click enter, for example, and I will set this. This is by default, the folder that I am having here, and I click enter, and after that I will execute this in my environment. Okay, so as you can see here, I will start execution, and I will see how the RSAC works. Another point during this scanning is, so how exactly where you can use in the RSAC. So here I will go to the RSAC, sorry, going to overview, and as you can see here, the RSAC analysis type. First is the SAST, as I mentioned, so does a statistical code vulnerability analysis, and the second is they can be done in the SRE code or a byte code or binary. So this is the main topic here, the main function using the RSAC, but they have two different analysis that I like, by the way, is about the leaks. I mean, the leaks checks to the source code for possible leaks credentials or private keys or hard-coded password. For example, if you have some hard-coded in your code, they appears to you because this is vulnerable. You can, sometimes you put in your code in a clear text. It's a terrible vulnerability, by the way. It's a misconfiguration, actually, not a vulnerability in the code. It's a misconfiguration because you give there, you take there the code. Okay, so dependence audit. You analyze the project dependencies to check the vulnerabilities for a third-party library, because sometimes you need to import some libraries in your code to execute something, and sometimes this library is vulnerable. So because of this, it's pretty nice you see about this library. It's a kind of dependence check, but it's pretty nice to see about this type. So for me, it's three different ways that different types that you can analyze. Okay, so I performed this in my environment. I execute this during this presentation. As you can see, the scanning about the RSAC. Okay, so let me return here. So where can you use the RSAC? Locally, as I'm using here my virtual machine, you can using this in your CI/CD pipeline. And if you are a developer, you can using this in your IDE extension in your VS Code. For now, it's just available an extension in VS Code. So this is how you can using the RSAC in two different ways, in not two and three, in a locally and a CI/CD pipeline in IDE like a VS Code. Okay, so let me return here, and okay, so let's see the log about the results of this scanning. Okay, let me return in the beginning. So here, as you can see, the type of the starting of this code and the finish time. So as you can see, and the first, let's see about the logs. First is leaks. The severity is totally critical. And first is the engine security tools. It's a RSAC engine. Okay, it's pretty nice in my opinion, because this is developed by the security team. In this case, not security team, but developed by the RSAC team. So the engine responsible to see this vulnerability. This is the file exactly vulnerable, right? In this case, the Python tdc.python. And as you can see, the code, take a look at this. This is not a password. In this case, you have here the hard-coded password, as I mentioned. So where is the exact explanation about this vulnerability? In this case, you can find here the main informations, not main information, the explanation about this vulnerability. And you can see here the link of the CWE. So Filipi, I don't know exactly what is CWE. So you can open the link and you can see here in the internet what is exactly this information. If you don't a security guide, for example. So basically CWE is a common weakness enumerations, right? So it's from Y3. And here is the total explanations about this vulnerability. In this case, the software contains hard-coded credentials, such as a password or a cryptographic key. And here is the extended description. And by the way, here you can see here the relationship of this main vulnerability. And the point is here, it's pretty nice if you don't have a guy. If you don't have a guy, or if you're not a guy of the security, you can. Here you have a good content to read and to learn more about the security, right? So have here the other variant of these vulnerabilities or different vulnerabilities is connected with this main vulnerability. And you can see here the many explanation, the many informations about this vulnerability. Here's some examples and how you can find in your code. So it's a guide, right, about the security, and you can use in your code. So here's some vulnerability. This is the ID of this vulnerability about the some on other vulnerabilities in different protocol, for example. So here potential mitigate, so how you can improve these vulnerabilities. And here you can see many informations about these vulnerabilities using a hard-coded credentials. Okay, so we have here a guide to suggest you to improve your knowledge if you're a developer guy. Okay, and take a look at this. In the second log, we have here Java. Okay, And take a look at this in this case, the 2-line and the colon 7. And here is the correct file that we can find the vulnerability. In this case, the app.java. Okay. And as you can see here, you have another different CWE. It's a 330. Okay. It's a different when you compare to the first. Okay. We have two different vulnerabilities and two different searches because the difference is the vulnerability is different. Okay. So let's go more another different. So here, take a look at this Python in this case. So take a look at this. This is the security tools is different. It's not from AutoSec. In this case, it is for Bandit. Right. So as you can see here, it's another engine. In this case, it's the open source engine. So another different tools that you can use to gather the AutoSec. From my perspective, it's pretty nice because you can combine all those engines. And if you see here below, take a look at this. You have a GoSec engine. It's another. You have more than one engine inside the same platform. So here you can have more than engines scanning your code. So here you can find others pretty nice information. Okay, so and in the end of this analysis, as you can see here, in this analysis, the total of the 10 possible vulnerabilities were found, and we classified them into 1 critical, right? So 1 totally critical, 2 highs, 3 medium, and 4 low. So as you can see here, you have 10 vulnerabilities in this. Remember, in this code here, in this case, in this folder. Okay, so if you see, I have here more than one project. Let's see, I have here 3 different projects in different programs. Okay, so and how, Filipe, I can use in this in VS Code, for example. So as I mentioned here, let's execute this. Okay, let me open my VS Code here at Sandbox. And let's see here, AutoSec. Here, AutoSec demo. Okay, so take a look at this. I have here the same project. Okay, so I have here my Golang code. I have here Java. I have here Node.js, Kotlin, the same code vulnerable. Okay, as you can see here in my VS Code, and I have here the extension. So basically, we click here and I write the AutoSec. Pretty simple. If you're using VS Code, for example, as you can see, you're just clicking in here, install, and after that, you have the extension here in your environment. It's pretty simple to use, basically. Let's see here. I just click in here in a start analysis, and after that, take a look at this. AutoSec started to analyze in your code, and as you can see here, they will execute this analysis in my source code. The same execution that I execute this in my environment. So let me explain more about another thing during this scanning was happening. Let me explain here about AutoSec. Let's check here the overview. It's not here. And about the installation, CLI installations one more time. And as I mentioned, I execute this locally, as I explained here. You can use here in the Windows platform if it works with the Windows, for example. You have here different versions about the Unix platform in Windows, and you can use in here in a Mac. And it is the process actually, and not the process. So here's the version on how you can use in NSAT they give the privilege actually. And here is the installations by image Docker, because you can use these in image Docker here. It's the command that you can use in your environment, and you can use in this the installation by pipeline. It's pretty nice. I think we have time to explain during this presentation. So I will be using the GitHub Actions to explain you to simulate the pipeline. Actually, you can use in this the AWS code build, so you can integrate. But basically, here is the step that you can use in the commands. The example here. You can use in this your Circle CI, for example, and your Jenkins in your Azure DevOps pipeline or in your GitHub CI/CD. So all those CI/CDs. It was tested by the AutoSec team, and this works pretty nice. Okay, so if you'd like to have another different CIs, you can test, or you can again using open some case or tickets, not tickets. It's not a ticket, but you can open you can write in the forum, and the security team in the AutoSec team can help you, right, to this project. Let's return here in this VS Code here. It's running, still running the AutoSec here. And by the way, I am doing the streaming, I am using the virtual machine, I am doing the scanning at the same time. So because of this, it's not too fast, but usually it's the 30 and 40 seconds to perform this. It's too fast. But in my case, I'm using the virtual machine. I'm doing the, I'm doing the streaming, the recording, many functions in the same machine, because it's more not too fast. Okay, so let's see here the TDC, this TDC.python. Take a look at this. When I click here, this is a totally critical. In the line exactly where you can find the vulnerability, you can put your mouse here below and take a look at this, the information. The same information that you find in the CLI. Okay, so take a look at this. You have here the hash reference about this vulnerability, and you have here the explanations about the leaks, remember, in the first log that I show you. Okay, and one more time here, the CWE, again, 79080. The same link that you can click here, and you can read more about this information if you don't know about what is exactly the CWE. And here it's another. Take a look, this is the AutoSec engine, the engine responsible to detect, to find in this vulnerability. And here you can see the bandit. So let's see another, the Java. Here it's the same. Click here, you can read more about this insecure random number generate. And here is the explanation why this random or insecure random number is vulnerable. Okay, not my definition, not definition from the Filipi or from Zupi or from AutoSec. It's definition from my group. Okay, the organization responsible for the vulnerabilities. And here it's another JavaScript. Take a look at this. This is another JavaScript using a shell interpreter when executing OS commands arbitrarily. Okay, so here it's another pretty nice explanation about this flow. And as you can see here, it's just for info, not info. It's in this case it's low, right? Based on GoSec engine. So as you can see here, the point that you can find exactly point that you can find the vulnerability. So for example, here you can set using some like a vault or another different solutions, and you can set the the environment, the secret environment. You don't pass, for example, here in the text, in the clear text. Okay, so here is the way that you can use it in the AutoSec, in your VS Code, in your IDE. Okay, so in the last one I will using in this case in the security, security in the GitHub Actions. So I have here my GitHub Actions. Okay, here my action, it's closed. It's not any job running for now, and I will return in my main code here. And if you click here, so you need to set the workflow right in this repository. So here, if you don't know how this works, you can click here and set up workflow yourself. And here is the information, so how you can create this folder. And here is the example that you can use in this case, right? So let me click in action one more time here. As you can see, none jobs running now. And I will create this folder here. .html not dash HTML, and I will go return here to the documentations, and I will pop this, and I'll explain more about the loop. Okay, so you pass here and take a look. First of all, I will create this job, the security pipelines, and take a look. This the job. Okay, I will run basically this command. It's the same command to install the AutoSec. Okay. And after that, I will execute the AutoSec start, and I will set the path. Basically, is the main path here that I'm running this, and I will set as another flag -e. I mean, in this case, it's true, because if in this case, if they found whatever vulnerability in this code, they will broke the pipeline. They create a gate to break the pipeline, and because the code is vulnerable and it is impossible to go to the production because the code is totally vulnerable. And by the way, in this case with Python, we have here the clear text. Remember that? Yes. Okay, I think you remember. So I create this. So let's see about my GitHub states. Okay, I think it's running now. Okay, just a log. So let me go, let me add this folder, let me commit. Our sec-demo, enter. So we have here the new folder, the new file actually. So I will push. I think I'm working with a master, not a main. Okay, so you need to set my password. In this case, I'm executing this new action. So let's return here in my GitHub actions. As you can see, none jobs running. I will click an action one more time and take a look what happened. So now I have the one workflow here, security pipeline. And if I click here, take a look at this. I am running now this new job in my GitHub actions. So I'm trying to see if my code is vulnerable or not. If not vulnerable, it's pass. Okay, but it's vulnerable. I will break because I set, remember the flag -e. In this case, it's true. The code needs to be -1. If they found some vulnerability in this code, they will break or create a gate in this pipeline. Okay, so they will executing this. Let me go to the job. So take a look at this, setting the environment, and after that they will check out the code, and now they will running RSAC in my environment. So if they found here any vulnerabilities, as you can see here, it's true. Here it's the same that I execute things in CLI and in the VS Code. And as you can see here, let me return here. As you can see, create a gate or break the pipeline. Okay, and here is the execution, right? So as you can see, execution the curl, and after that they set the RSAC start -p and -e if vulnerable. And let's see the logs. So take a look at this. It's basically 1 minute in this case. Take a look at this. The same vulnerability that we found since the first, right? In the CLI and VS Code. Okay. Others about main information about the logs, and take a look at this. The password, the secret, and the Python. In this case, in a clear test, one more time, password 123. Okay, and another is this is not a password. Okay, and here, as you can see, in this case, more than one possibility. Okay, and take a look at this error process completed with the exit code 1, because I set the flag, remember? And as you can see, the code, it was broken. In this case, I can send many informations. I can send these informations to the web manager, but we don't have to explain more during this presentation. And after that, you can treat all those vulnerability, and you can changing this code. And after that, you can rerun the job. If the code was pretty nice, so they will pass. Okay, guys. So I finish here my presentation. I don't know if you have any questions. So if you have any questions, so please let me know. I hope this presentation should be useful for you. And one more time, thank you so much for being here during these presentations, and see you in the next event.